Hi, this video is on adding vectors. So suppose we want to add the following vectors. A is a vector 8 meters per second east, and B is a vector 6 meters per second south. What we're going to do is draw what's known as a vector diagram. So we're going to draw, first of all, vector A. So vector A is a vector pointing east. So here's my vector 8 meters per second, and I'm drawing it pointing in the east direction. Then I want to add to that vector B, and I'm going to add vector B starting at the head of vector A. So wherever vector A ended, I'm going to draw B going south at 6 meters per second. And I'm going to try and draw the length, the relative length of the vectors. So here's vector A, which was 8, so vector B is 6, so it should be slightly less. And the sum of these two vectors is the vector drawn from the tail of A to the head of B. So this vector here is the sum, A plus B. So how do we find then the magnitude of that vector A plus B? Well, this is a right angle triangle. We know that this angle here is 90 degrees because this line is pointing east and this line is pointing south. So for a 90-degree triangle, we know our friend Pythagoras determined the relationship between those sides. Right? We have the Pythagorean theorem. So that side, A plus B, is going to be the square root of 8 squared plus 6 squared. And when we put that into our calculator, what we find is that A plus B is a vector that is 10 meters per second. So we've used our Pythagorean theorem to find the length of this vector. But now I also want to know the direction. Remember that vectors always include a direction. So I need to know that angle. And I can use a basic trig identity like our tangent to find that vector. And we know that tan of theta is always going to be the opposite over the adjacent. So in this case, the opposite side of this angle, opposite being the 6 meters per second, over the adjacent side, which is going to be the 8 meters per second. And when we put that into our calculator and do the inverse tan, we find that that angle is 37 degrees. So our resultant, A plus B, is a vector 10 meters per second at an angle of 37 degrees. And as always with angles, it's not enough just to give the angle. 37 degrees in which direction? So this angle is the angle starting from this line, which is east, and going this direction towards south. So this is south of east. So that would be our final answer for the sum of A plus B. Okay, what if we wanted to add these two vectors? This time, our two vectors are not going to give us a right angle triangle. And for this one, I'm going to make life a little bit easier on myself by starting off by drawing the coordinate system. And looking at my vectors, since they're using north, south, east, west, I'm going to label these north and east. And I'm going to start like I did with the previous example with vector A. So I'm going to start at the origin and draw vector A over here. And it's at an angle of 30 degrees north of east. And it's 6 newtons. And then I want to draw a vector B, slightly shorter vector, but it points north. And that's 4 newtons. And that gives me the sum of those two vectors, vector A plus B. And again, it's this vector drawn from the tail of A to the head of B. So this is my resultant, A plus B. So I need to find the magnitude of that vector and also the direction. Now the direction will be this angle that the vector makes with east. So it's going to be so many degrees north of east. And that is going to be 30 degrees plus this angle in here, which I'm going to label as theta. Now, to find the magnitude of this vector, I can't use the Pythagorean theorem because this is not a right angle triangle. So I have to use something called cosine law. And the cosine law looks like the Pythagorean theorem, but it has this extra term added to it. And this extra term involves the cosine of angle C. And angle C is going to be, it's going to be this angle here. And this angle is going to be this 90-degree angle here plus this angle down here. And this angle is actually the same as this angle, right? This blue vector relative to this horizontal line makes an angle of 30 degrees. So here's a horizontal line, and this angle is 30 degrees. So that makes this angle here 90 plus 30, so it's 120 degrees. So back to my cosine law, c squared is going to be 6 squared plus 4 squared minus 2 times 6 times 4 times cosine of that 120 degrees. And our calculator should tell us that the length of this vector is 8.7 newtons. So my cosine law has determined the length of this vector, even though I don't have a right angle triangle. Now, to find this little angle in here, we're going to use something called the sine law. And the sine law means that I can take any two sides. In this case, I'm using sine of angle B and side B, and setting that equal to the sine of angle C and side C, because I know this angle, and I know this side, and I know this side, and I'm looking for this angle. So that means sine of that angle over 4 is equal to sine of 120 over the length that we just calculated, which was 8.7. And again, my calculator tells me that that is an angle of 23 degrees. And don't forget, that's the angle that we need to add to 30 to get my final direction. So as a final answer here, A plus B is 8.7 newtons, and it's at an angle of 53 degrees north of east. So when you have a non-right angle triangle, you're going to use the cosine law and sine law to solve for the magnitude and direction. Okay. So those two examples should help you out with almost all of the questions we're going to do this year on adding and subtracting vectors. If that doesn't make sense to you, you can always come and ask me in class. Try out some of the practice problems that I've put onto the website, and good luck.